Welcome to the short version of our KAI 2021 Late-Breaking Work Conference presentation. Here you can learn about our exploration into designing lower-risk digital self-control tools, as well as our prototype low-risk digital self-control tool. Why are low-risk digital self-control tools important? First, digital interfaces are often designed to cause users to spend the maximum amount of time or money possible. In response, some users are concerned by the amount or quality of time they spend using digital interfaces, which has created a niche for applications to help individuals control their usage. These apps are called Digital Self-Control Tools, or DSCTs. At the same time, DSCTs and other behavior change technologies are often abandoned, frequently due to user reactance against the tool. There has also been a strong previous research focus on increasing efficacy as the primary goal of interest for DSCTs, rather than reducing risk of abandonment. All of these points led us to recognize low-risk digital self-control tools as an important, yet relatively unexplored area of investigation. We refer to low-risk interventions as those that emphasize long-term reliability over short-term behavioral change. Before we began our project on designing low-risk DSCTs, we completed a qualitative review of DSCT literature and created a framework of DSCT core principles: minimization of reactance, efficacy, alignment of user behavior with user goals, voluntariness, privacy, and non-deception. We wanted to be certain that we were continuing with established guidelines when proposing low-risk DSCTs. In this list of core principles, the outcomes are often contradictory. For example, a DSCT that aligns user behavior very well with user goals may also cause high reactance if the tool needs to frequently ask the user for updated goals. In this late-breaking work, we are particularly interested in how risk and effectiveness may conflict. We propose that increasing the short-term effectiveness of a DSCT is positively correlated with an increasing risk of DSCT abandonment. The data points here are just to model this proposed relationship. Some previous research has also quantitatively explored how DSCT risk and effectiveness relate. To complement our weak principle of risk and effectiveness, we also propose a strong principle of risk and effectiveness in DSCTs. We propose that risk increases with ideal effectiveness, given that the lowest risk intervention in each effectiveness class is selected. In other words, it should always be possible to decrease the risk of a DSCT by selecting a lower effectiveness intervention. Again, the data points here are just to model this proposed relationship. Let's move to some of the design patterns we propose for low-risk digital self-control tools. The first design pattern we propose is the use of continuously variable interventions, those that can be adjusted from off to any level of effectiveness. As opposed to other interventions which can only be turned on or off, such as blocking an element on a page, continuously variable interventions can be fully increased or decreased. The second design pattern we propose is anti-aging design, that is, the design of a DSCT to be especially adaptable to changes in its environment. From a software development perspective, we aim to reduce software aging, which can be accomplished by centralizing features, that is, ensuring compatibility with a larger variety of environments, or by making some features redundant, that is, reducing the risk that the environment would cause the DSCT to fail entirely. The third design pattern we propose is obligatory bundling of interventions within a DSCT. In this case, we aim to reduce the likelihood that a highly risky selection of interventions would cause the tool to fail completely. This is accomplished by forcing lower risk interventions to be adopted alongside higher risk interventions, or by removing interventions from a DSCT that are particularly poorly tolerated by users. The last design pattern we propose is the use of an intermediary control system within a DSCT. In this design pattern, we reduce the ability of the user to control the DSCT in exchange for controlling it in a way that can reduce risk. For example, a user might select a mix of interventions that could cause multiplicative effects. With an intermediary control system, we can simplify user choices so that the user does not pick individual interventions and instead picks overall goals. Then we can leave the details up to the intermediary control system. Next, we introduce our low-risk DSCT, Time Sidekick. It is an extension for the Google Chrome browser, and it influences the user's browsing by causing small delays to initial content that is loaded in a page or content that is dynamically loaded. Both of these interventions are continuously variable, both of them are generalizable to a wide range of websites, both of them are used together in a bundle, and the user interacts with the interface above, which is an intermediary control system. In other words, the user can only control the DSCT by turning it on or off for certain websites. Currently, we are conducting a pilot research study to evaluate how well these low-risk interventions are tolerated. Concretely, are low-risk interventions accepted among users? What effect sizes can we see with these interventions? Does increasing intervention effectiveness cause increased abandonment or an increased desire to abandon the tool? In this slide, we provide a visualization of some real browsing data collected over 24 hours from users. Users blend ordinary browsing with sites they wish to reduce, as well as other break activities.